Now, let us start about fourth question, which says use Euclid's division lemma to show the square of any positive integer is either of the form 3m or 3m plus 1 for some integer m. See, Euclid's division lemma says a is equal to bq plus r. We must know r, which is remainder, will never be more than 0. Therefore, will never be less than 0. It can be either more or it can be 0. And it should always be less than b divisor. This is the condition. Remainder is either equal to 0 or more than 0 and should always be less than divisor. This is the condition. This is Euclid's division lemma's condition. Now, let us start, and we know the value of b here in this question, which is 3. So for the calculation, we use b as 3, and we'll start now answering. So what we do now, let us take a. Let a be any positive integer. Now, we also should know what all the possible values of r. When we have 3 as b, possible values of r is equal to 0, 1 and 2. We should always remember when b is 3, r value should be 1 and 2 only. When it is 4, it becomes 1, 2, 3. So it should be always less than this number. So the possible values of r will be 0, 1 and 2. We are going to substitute this value in this so that we arrive at the answer. To start with, we take r as 0, right? And take this a plus bq, a is equal to bq plus r. Now put 0 here, it becomes a equals aq, bq. Now value of b is 3, therefore a will be equal to 3q. This is number 1. What you have to do now, you have to square both sides. Square both sides. We must remember that in mathematics, LHS will be equal to RHS. When you square one side, you have to square the other side to make sure that the value does not change. Similarly here, once a square will be equal to 3q whole square. We have squared both LHS and RHS. A square is equal to 3q whole square. When we open this becomes a square equals 9q square. To get our answer 3m, what we do, we break this into 3 into 3 like this. The value does not change. 3 into 3 is 9, q square is there. All we have done is taken out 3 separately and 3q square becomes some integer. So what we do, we put let m be equal to 3q square. This is already written in the question itself, some integer m. So this is some integer. Therefore, this you can treat as m. A square is equal to 3m. This is one observation. The second observation is when the r value is taken as 1. It is this. R value is taken as 1 or is equal to 1. Put this value in our equation bq plus r. A is equal to b is 3, q is written as it is, and this is 1. Now you have to square both sides. square both sides. Then this becomes a square 3 cube plus 1 whole square. Please remember, put the brackets for the 4 RHS and then square it. Now this follows the identity a plus b whole square, which is equal to a square plus b square plus 2ab. Use this identity to solve this. This becomes 9q square plus 1 square is 1 plus 2 into 3q into 1, which is 9q square plus 1 plus 3 into 2 is 6q. Now put this 9q square and 6q together plus 1 at the last. Now a square is equal to, take 3 out, 3q square plus 2q plus 1. Please remember, this is some integer which is represented by letter m. After this, a square becomes 3m plus 1 because, as I say, whatever is written in the bracket is some integer which we want to represent by the letter m, which is already written in the question itself, some integer m. So this is some integer, and this you can write as m. We finally arrive at a square, which is equal to 3m plus 1. This is case 2.